What would you say if you found out that the Earth is flat? How would you feel if you realized that everyone around you is speaking an unfamiliar language? How shocked would you be if you found yourself on another planet? Indeed, people feel much more at ease in familiar circumstances, which is why most people don't like change. But it seems that change is exactly what awaits us, and on a global scale. We're talking about the discoveries made by the James Webb Telescope. They have overnight undermined the very laws that our entire cosmology has relied on for many years. The James Webb Infrared Telescope, which only recently began its mission, has already managed to seriously astonish the scientific community. It has discovered several galaxies whose ages are too great for their existence to be possible. Moreover, one of them is older than the Big Bang itself, which is simply unthinkable if we rely on the generally accepted hypotheses. What could this mean for humanity, and how will it affect the fundamental laws we have believed in until now? Hubble. Subscribe. The Big Bang Theory and Hubble's law are the absolute basics. Most of our ideas about the macro worlds surrounding Earth are based on them. Every school kid knows that the Big Bang happened about 14 billion years ago. This was preceded by a singularity point which suddenly detonated and the universe began its expansion, which continues to this day. Next comes Hubble's law, which is the universal recession of galaxies. This is also a basic cosmological law that explains the very expansion of the universe. So what did James Webb do? He aimed for the Holy of Holies, trying to destroy the foundation on which our astronomy has stood until now. Considering that right after the explosion, large bright galaxies with metallic stars couldn't possibly have formed, the telescope's discoveries are rather puzzling. The thing is, according to modern scientific theories, hydrogen stars had to appear first, and by exploding at the end of their life cycle, they would fill the empty universe with building materials. It was from them that more mature stars and galaxies were supposed to form later on. Then how can we explain the fact that James Webb discovered Cosmic Evolution Early Release Science 2112? This is a fully mature star cluster that formed just 2.1 billion years after the Big Bang, which is absolutely impossible if you pay attention to its density and structure. This barred spiral galaxy, much like the Milky Way, has a mass nearly 4 billion times greater than the Sun. Do you think that's all the finds? No, because there's also the galaxy AZTECC 71, shaped like a giant drop, which the telescope discovered in December 2023. These galaxies are classified in a separate group called Hubble's dark galaxies. A scientist from the University of Texas in Austin believes that the discovered monster is a real star factory, since the process of star formation inside AZTECC 71 never stops. It is estimated that about 1,000 new stars are born in it every year. But the most amazing discovery made by the James Webb Telescope happened in 2022. This is the galaxy JADESGS Z130. This object is the most distant ever discovered using ground-based optics. It is believed that the galaxy formed just 320 million years after the Big Bang, which is impossible. But to claim otherwise would mean not trusting your own eyes and the readings of ultra-precise equipment. According to the generally accepted cosmological theory, active star formation began approximately between 550 and 800 million years after the Big Bang. Yes, these celestial bodies were mostly hydrogen. Galaxy clusters or metal-rich stars were not mentioned. And here we have an entire galaxy that, judging by its age, formed even before the Dark Ages, a period in which stars, by definition, did not exist. But the fact remains. The telescope's equipment states that the galaxy's age is 13.6 billion light years, and if you adjust for the expansion of the universe, that's about 33.6 billion light years. An enormous age, absolutely impossible if you rely on the Big Bang theory. This galaxy is located in the constellation Fornax. Some astronomers even suggest that it's a dark star with a mass equivalent to 1 million suns. What does this mean? If the James Webb Telescope found only one such galaxy, it could be called a coincidence. But 3 objects suggest a pattern. Besides, we forgot to mention the galaxy HD1 in the constellation Sextans and Glass Z12. At the moment, they share first place with JADESGS Z130. It is believed that HD1 may be inhabited by first-generation stars that appeared right after the Big Bang, but as the famous meme says, that's not certain. Glass Z12 is most likely a dwarf galaxy, about 60 times smaller in diameter than the Milky Way. Think about this as well. Since these galaxies are so old, their formation must have started well before the Big Bang. Isn't this the collapse of widely accepted theories? Among all the telescopes we have at our disposal at the moment, James Webb is the most advanced, especially in terms of its optical system. So there is no reason not to trust its data. But you know what's most surprising and frightening? Not a single Earth-based telescope, whether ground-based or orbital, has yet discovered young or infant galaxies in the universe with a small number of hydrogen stars. All the objects whose photos and data are sent to us by optical instruments are fully formed, filled with a huge number of stars, and are very complex in their structure. How can this phenomenon be explained from the point of view of standard cosmology? You might ask, why rely on it at all? Isn't it possible to try to come up with a fundamentally new explanation? But the global scientific community has no intention of doing that. Its goal is to fit the obtained data to the already existing theories. On the other hand, you can understand them because breaking is not the same as building, but it's not enough to just ignore the obvious. You also have to come up with an explanation for it. So how do scientists explain the fact that there are such old, fully formed galaxies where they shouldn't exist? The first explanation is explosive star formation. This theory is meant to justify the appearance of extremely bright stars and galaxies in the deepest parts of space. In this case, a simulation created by a supercomputer comes to the rescue. As a result, it turned out that in the dawn of time, explosive star formation was a common phenomenon. What does that mean? It is believed that back then, the appearance of stars was accompanied by periodic bursts, which accounted for the brightness of ancient galaxies. They say that nowadays star clusters are calm and stable, but things were different in the past. By the way, astronomers use the term starburst for galaxies of small mass, which is what those that formed shortly after the birth of our universe were. Thus, scientists boldly brought the facts together and concluded that the unexpected brightness of ancient galaxies was due not to their gigantic size and density, but to starburst activity. One example of such an object is the Messier 82 galaxy. In it, stars are born 10 times faster than in the Milky Way. It is located in a dense dust cloud, but the advantage of James Webb is the ability to observe objects in the infrared range. The second explanation is the aging of light. This hypothesis sounds rather strange, and it practically refutes Hubble's law, which states that the universe is expanding, where galaxies moving away from us are in the red range, and those approaching are in the blue. Physicist Fritz Zwicky in 1929 tried to refute Hubble's conclusions. He claimed that as light travels through the universe, it simply ages, which causes the redshift. To put it even more simply, photons of light lose energy due to scattering in space and the influence of gravity from objects they pass by. Thus, Zwicky claimed that there is no expansion at all, and the universe is absolutely static. For a while, the hypothesis was gathering dust on the shelves, but now it has come into a new light. Sorry for the pun. The thing is, the Indian scientist Gupta, who works at one of the Canadian universities, decided to combine the tired light theory with the theory of the expanding universe, so to speak, reconciling their postulates. So what does this imply? The astronomer concluded that, in fact, taking into account the aforementioned theories, the Big Bang happened much earlier, namely more than 26 billion years ago. So the light we observe has aged considerably during this time. Explanation 3, the theory of variable constants of nature. It's quite simple to understand. It states that the laws of the early universe and those that govern everything now are two very different things. That is, the constants we now rely on as something monumental could have changed over time. It's also worth mentioning modified Newtonian dynamics, or the modified Newtonian dynamics theory. In it, Israeli physicist Mordechai Milgram tried to explain the rotation of galaxies without including dark matter in the formula. All of this together, according to some astronomers, is meant to explain certain discrepancies between our laws and the data we've obtained. Did the explanations and theories above convince you or make you doubt the Big Bang Theory, Hubble's law, and other cosmological postulates that have dominated the scientific world for many years? To be honest, we're confused. The only conclusion we can draw from this situation is that everything we were sure of is collapsing right now. Towers that seemed solid are falling, foundations are sinking, and the structures are breaking down. James Webb chose the language of facts, which are very hard to argue with or fit into convenient frameworks. So for now, we suggest taking the position of an observer, grabbing some popcorn, and continuing to watch this cosmic spectacle. For many centuries, the solar system was a mysterious world to us. Our ancestors had only a vague idea of what it looked like. Over time, the veil of mystery began to lift. We got our first telescopes and later probes that could get close enough to the objects in the solar system to see them clearly. We even managed to get closer to the sun. These images look more like scenes from a science fiction movie, but in reality, they show the actual shapes of planets and other objects in the solar system. Get ready to witness a fantastic spectacle. 1979. Both Voyagers came close to Jupiter. As a result, there were as many as 33,000 different photos of the planet and its moons. This helped to reveal some of the mysteries of the gas giant. For example, Voyager 1 took a rather clear and detailed image of the Great Red Spot, and we were finally able to take a good look at it. In 2016, the Juno spacecraft became the first probe to pass through Jupiter's dense clouds, something no previous probe had achieved. Juno not only took very high-quality photos of the surface for us, but also used microwave frequencies to study the possible level of water in the atmospheric layer. In this image, you can see the features of Jupiter's clouds. The contrast was increased in the photo for this purpose. A year later, Juno captured the clouds in the tropical zone of the gas giant. There, they are quite large. One structure is about 50 kilometers wide and high. In this image, we see something that looks like lightning, most likely because the clouds are made of water and ammonia ice. This could contribute to the appearance of lightning. On Jupiter, wind currents reach very high speeds, from 60 to 428 kilometers per hour. That's a characteristic of the gas giant's atmosphere. Here, Juno, when it was closest to the planet, took a picture of stream number 3. You can see the smallest details in the image. The quality of the images improved as it got closer to Jupiter. Here's another picture from Juno. This is a powerful storm that appears near the polar regions once every 5 weeks. Juno didn't stop there. It also managed to capture the northern cyclones of the gas giant, which have lasted for 5 years. And we know that there's more to come because Juno will complete its mission only in 2025. It's worth noting that lighting conditions can often completely change the appearance of an object. If we work on the characteristics of a photo, for example, by increasing the saturation, we can see things we hadn't noticed before. In the case of Jupiter, scientists often experimented. Meanwhile, the James Webb Telescope also continues to delight us with new materials. Thanks to it, we have the most recent images of Jupiter to date. The gas giant's moons were not ignored either. Voyager 1 gave us an image of the surface of Ganymede, the largest moon not only of Jupiter, but of the entire solar system. The lighter areas are younger, more elevated formations, while the darker ones are older. There are also more detailed images of the moon, like this one. Here you can take a closer look at the mountainous terrain. The moon Callisto is often called the twin of the moon. Their surfaces are very similar in many ways. Callisto is also covered with impact craters. And here, in this image from 2001 taken by the Cassini spacecraft, you can see Io. Another moon. Here's a more detailed image. It is believed that there are about 400 active volcanoes on Io. One of them is called Ra Patera, and it erupts a huge amount of lava. Io's terrain is very diverse, with mountains even taller than those on Earth. And here is another moon, Europa. The Juno spacecraft approached it at a distance of 350 kilometers. Europa's surface is also uneven, with many depressions, mountain ridges, and cracks. In some places, you can also see fragments of ice. Scientists suggest that the reason for its appearance could be an internal ocean with liquid water. Whether it is really there, we cannot know for sure yet. Meanwhile, we move on to Saturn, another gas giant which is located 645 million kilometers away from Jupiter. Of course, the distinctive feature of this planet is its ring system, made up of cosmic dust, fragments of asteroids, and comets. They were first noticed by Galileo Galilei with his telescope, although at that time he didn't realize he was seeing rings. Initially, he believed that these were two moons located in closely spaced orbits. In the 1980s, Voyager got close enough to Saturn for us to get such incredible images. Cassini went further, giving us images of Saturn that revealed previously undiscovered moons. The probe also captured a powerful vortex, spinning at a speed of 2,000 kilometers per hour. The colors here were adjusted to show the wavelength of near-infrared radiation. Thanks to this, we can understand, for example, exactly how the clouds are arranged. Red means low relative to the surface, and green means high. Cassini also took this interesting picture of Saturn's clouds. There is a large amount of methane in the atmosphere of the gas giant, so sunlight is absorbed and scattered by the atmosphere. On Saturn, the northern lights are different from those on Earth. On Earth, they look like this. But we can't see the northern lights on Saturn just like that, because it only appears in infrared radiation when the atmosphere interacts with the solar wind. However, now we're going to show you something on a larger scale. This is a panorama of Saturn, which was created from 165 different images. This is truly something incredible. We shouldn't overlook Saturn's moons either. Among them, one of the most interesting is Enceladus. It has very high geological activity and a huge number of geysers that leave a trail behind as the moon moves along its orbit. This is clearly visible in one of the images. Interestingly, this trail doesn't go anywhere and actually forms a ring around Saturn as well. Also, based on data from Cassini, a complete map of Enceladus was created. On it, we can see a region in the north that's covered with craters. This means that the terrain here is quite ancient and hasn't been renewed for a long time, but in the south, it's the opposite. Most likely, there are hydrothermal vents beneath the surface. In theory, they can create optimal conditions for the existence of simple forms of organisms. Another moon of Saturn is Titan. Not only is it the largest moon of this planet, but it's also an object where life could exist. The Cassini spacecraft found traces of lakes on it, which were mostly made up of ethane and methane. The lakes appeared as a result of gas release. Liquid nitrogen beneath the surface heats up, turns into a gas, and leaves a depression behind. This, for example, is a rather interesting image of Lake Kivu Lacus. You can see a reflection in it. Vast areas of liquid on the surface of the satellite may indicate the presence of entire seas. There is a theory that life could exist in these basins that does not require a water environment. Hydrocarbon-based in its composition, it could very well exist in methane lakes. Voyager 2, during its long journey, approached Uranus. It can rightfully be called an ice giant, which has clouds, the northern lights, and even a ring system, although not as noticeable as Saturn's. Voyager managed to take several images. However, soon we will get more from James Webb. The telescope has already given us an image of Uranus and its 6 moons, and now we move on to our main star, the Sun. Now we are getting more and more impressive images. Previously, we couldn't get close to the Sun at an optimal distance because its temperature reaches millions of degrees. The situation changed with modern telescopes and advanced spacecraft, and now National Aeronautics and Space Administration has launched the Parker probe, which was able to fly through the outer layer of the Sun's atmosphere, where the temperature reaches 1,100,000 degrees Celsius. As a result, we got this image. Images of our solar system continue to amaze us, even though it seems like we've already seen everything. In fact, our nearest cosmic neighborhood still hides many amazing and unknown things. Discoveries await us that can still amaze our imagination. Have you ever played hide and seek? Most of us would answer yes to this question. Do you think it's hard to look for a black cat in a dark room if it's not there? But this is exactly the pointless task our astronomers have been doing for several centuries. What exactly are they looking for? They're trying to find at least a hint of traces of extraterrestrial civilizations. But are their efforts really in vain? Maybe there is some kind of critical obstacle that kills life at a certain stage of its development. The first thing that really prevents us from analyzing the situation objectively is our view of extraterrestrial life. How can you imagine, let alone identify, something you've never seen? Let's use a simple analogy. Suppose you've spent your entire life in an underground colony. Something like in Glukhovsky's work, Metro 2033. Since birth, you've only seen iron and stone structures around you, as well as other beings like yourself, but not a single plant. And then suddenly, you're brought up to the surface and placed in the depths of a botanical garden. They also say grass, flowers, and trees are as alive as people. How would you react to this and interact with them? And if you hadn't been told, would an oak tree or a rose seem like living beings to you? In science fiction literature, there are many examples of misunderstandings between humans and aliens because other forms of life can be very different from us. For example, in Stanislav Lem's novel Solaris, it's about an intelligent ocean, but it's impossible to establish productive contact with it. Although attempts were actively made from both sides, what conclusion should we draw? Most likely there will be a huge number of limitations and obstacles for interaction between different bioforms, both for human civilization and for the alien one. That is, perhaps we simply do not hear or see each other. And all because, to quote a line from the novel Solaris, we are not looking for anyone except humans. We don't need other worlds, we need a mirror. But what are Earth scientists doing to create a universal tool for communicating with potential extraterrestrial intelligence? Unfortunately, the approach doesn't change here either. The proof of this is Linkos, a constructed language fundamentally different from Esperanto, created by mathematician Freudenthal specifically for exchanging information with extraterrestrial civilizations. So we're making the same mistake again. It's assumed that aliens must necessarily communicate using language and not by any other means. However, differences remain. This communication method is based on the universal language of mathematics, but this will only be effective if alien life is guided by similar laws. 2 such messages have already been sent into space in 1999 and in 2003. There is no answer yet. It makes you want to use Enrico Fermi's famous question, so where is everybody? Frank Donald Drake, who developed the equation estimating extraterrestrial civilizations in our galaxy, ultimately lived in vain. After all, according to his formula, there should be plenty of highly developed worlds around us. Let's not start with catastrophic theories and describe possible obstacles to the development of civilization due to some irreversible events. Let's save that for dessert. But for now, it's worth remembering what distinguishes artificial intelligence from the human brain. Without going into boring details, the first thing that stands out is the monstrous slowness of our gray matter. It's enough to say that for thinking over a complex question, an ordinary computer needs just 1 second, while for us, it would take at least a month. So artificial intelligence is 3 million times faster than the human mind. Thus, it's possible that we are simply too uninteresting and predictable for higher forms of life. You don't try to make intelligent contact with ants, do you? And then should we really be shouting so loudly in the hostile cosmic jungle, persistently announcing our existence to those around us? And do we really know for sure who inhabits the darkness of the universe? The era of catastrophic theories has arrived. Many famous people of their time, such as Arthur Clarke, Carl Sagan, Nick Bostrom, and Stephen Hawking, seriously talked about how it would be better for us not to stick our necks out by sending messages to different parts of the galaxy. You may ask why, but it's obvious. Look at how humanity reacts to the rapid development of artificial intelligence. We fear that computers will one day successfully pass the Turing test, gain self-awareness, and start making their own decisions that go against ours. Remember the fantastic uprising of the machines. Where are we going with this? The point is, there's a high probability that some kind of great filter exists, and we might very well run into it. According to this hypothesis, proposed by the futurist Robin Hanson, there's a mechanism built into the fabric of the universe that destroys a civilization if it advances to the point where its activities can be detected by outside observers. So basically, it's like suffering from too much intelligence. If we extrapolate this conclusion to human civilization, then the more successful and faster we move toward technological and cognitive singularity, the worse our chances of survival in the future become. Perhaps it was the great filter that destroyed all formations that reached the third level on the Kardashev scale. Let me remind you, civilizations at this stage use the energy not only of their parent star, but also of their own galaxy. Naturally, such a formation is noticeable from afar by its megastructures, Dyson spheres or swarms, as well as by the active expansion of representatives of a highly developed society, spreading its spores to other planets. At what stage can the great filter come into play? Reaching a Type 3 civilization requires going through at least 9 steps. Of course, that's again from the perspective of Earth scientists. It's likely not the only path. In short, first a star with several planets forms. Then, on one of them, conditions for the emergence of life appear. At first, simple life forms appear, then more complex, single-celled organisms, after which eukaryotes begin to reproduce actively. As a result, multicellular organisms emerge, gradually developing into Homo sapiens. But here, let's stop. As long as this individual evolves without leaving their own planet or its immediate surroundings, there's no need to worry. But as soon as a civilization globally increases its energy consumption and begins the process of colonizing other celestial bodies, the barrier that destroys upstarts will activate its mechanism. What could the great filter threaten us with? Anything, from the self-destruction of civilization to a cosmic or natural cataclysm. Judging by the fact that the Milky Way is empty, at least there is no evidence of intelligent life in it besides humans, it is extremely unlikely and most likely impossible to overcome this barrier. What exactly could stop us from developing? Since Earth is just a celestial body on the hostile canvas of space, no one can guarantee that in 100 years, or even tomorrow, the planet won't be struck by an asteroid. If its diameter is about 1 kilometer or more, then modern human society could very well be reset to factory settings, meaning back to the Stone Age. As they say, our song is good, let's start from the top, and that's not even mentioning the deadly gamma ray burst from a supernova explosion, whose sterilizing beam wipes out even the slightest trace of once flourishing life for many millions of years. Or about an alien attack by slightly more advanced organisms. Why not assume that since we're shouting about ourselves to the whole galaxy, there's no need to wait for an outside threat? We are quite capable of destroying ourselves, for example, by starting a global nuclear war, which will inevitably lead to an environmental disaster, resource depletion, and mass extinction. This also includes a deadly virus that could wipe out half the world, or the creation of something like a hadron collider with catastrophic consequences. There are quite a few possibilities here. The third type of great filter scenario is the eruption of a supervolcano, such as Yellowstone, which would lead to an increase in the greenhouse effect, climate change, multiple tsunamis, in short, a suicidal chain reaction. It turns out that if a human colony ever appears on Mars, and its members accidentally discover the ruins of an ancient, highly developed city, it would be the worst news in the history of human civilization, because it would hint the end is near. Now listen to the great silence of the universe and try to form your own opinion about what destroyed them all. When the truth is revealed, perhaps we will be able to avoid a sad ending. Meanwhile, let's enjoy life. Are you attracted to eternal life? Have you ever wanted to witness the distant future without fearing inevitable death? The topic of immortality has interested people since ancient times. Humanity has always been drawn to eternity, and we've always searched for ways to extend life or even achieve complete immortality. You've probably heard more than once about the Philosopher's Stone, a mythical artifact that alchemists supposedly used to turn various base metals into gold and silver. But most importantly, it could be used to create the elixir of life. It was also called potable gold. The drink was supposed to be taken in small doses, gradually healing your body from all ailments. The ultimate goal was immortality itself. Now, the Philosopher's Stone is a beautiful myth. No one knows if anyone was ever able to actually create it. There were rumors that Nicolas Flamel, a French patron and alchemist, actually created the stone that grants eternal life. The reason for these rumors was that Flamel lived quite a long life for those times, 88 years. And even after his death, people believed that the alchemist had simply faked his death to avoid arousing unnecessary suspicion. This is a story from the 14th century, but you can find examples even in ancient times. The Epic of Gilgamesh is famous for telling the story of a Sumerian king. After his friend Enkidu dies, Gilgamesh starts reflecting on his own mortality, realizing he will also die someday. That is why the Sumerian ruler wandered for a long time in thought until he met Utnapishtim. He survived during the Great Flood, founded a new line of humanity, and as a reward, the god Enki granted him immortality. Utnapishtim revealed the secret to Gilgamesh. It turns out that at the bottom of the primordial ocean grows a flower that grants eternal life. Gilgamesh, with great difficulty, managed to obtain this flower, but soon it was stolen by a snake. Since then, snakes have prolonged their youth by shedding their skin and growing a new one. As for humankind, they have remained mortal. Now, times are completely different, but the topic of immortality is still on the agenda, this time among scientists. So what are people saying about immortality and the possibility of achieving it now? And what consequences might a person who gains eternal life face? The key concept in the question of eternal life is aging. Aging is exactly the factor that stands in the way of immortality. After all, as we age, the ability of all the components in the body to work together smoothly disappears. Elderly people don't die of old age, paradoxical as it may sound. They die from diseases that arise as a result of the body's declining functionality. The animal world gives us a vast field for observing almost immortal creatures. One of the most amazing is the naked mole rat, a strange little underground creature that doesn't have the ability to age. The mole rat is mortal, of course, but it dies either from fights with enemies or from heart failure and other vital organs stopping. Who knows? Maybe these underground creatures will one day reveal the secret of their eternal youth. Telomeres play an important role in the aging of the body. They are located at the ends of linear chromosomes, protecting them from damage. Over time, the length of telomeres decreases. This leads to the aging of cells. Accordingly, in order to preserve the youthfulness of the body and ensure a longer life, We need drugs that will restore telomeres. Something like this might be invented in the future, but for now, it's still far off. There is a more interesting option, the so-called quantum immortality. This is a theory according to which a person will actually never die. Our consciousness shifts to a nearly identical universe with some differences at death. Thus, a person simply doesn't notice that they have ceased to exist in one universe. Thus, we live forever, constantly moving from one parallel world to another. Does this theory have a scientific basis? Quantum mechanics played a role here. If we're talking about the so-called superposition of a particle, it can exist in several states at once, but at the moment of measurement, the particle is in one of the possible states. This is the Copenhagen interpretation of quantum mechanics. However, we are interested in the many worlds interpretation of quantum mechanics. That is, for a certain object, there are two or more possible developments of events for different universes. The absurdity of this statement was attempted to be proven by the Austrian physicist Erwin Schrödinger with the help of a hypothetical cat. You have probably heard at least once about Schrödinger's cat. According to the experiment, if the box stays closed, the cat is both alive and dead for an entire hour. The Copenhagen interpretation of quantum mechanics states that the cat is either alive or dead, while the many worlds interpretation tells us that in one universe the cat is dead and in another it is alive. There is another similar experiment called quantum suicide. Imagine a gun is pointed at a person. It will either fire or it won't. The probability is the same. Again, from the perspective of the many worlds interpretation of quantum mechanics, in one universe the shot will happen and in another it won't. What makes a person who they are? Is it the body appearance, or is it our thoughts, our views on life, in a word, our consciousness? What if the essence of immortality is to preserve the essence, not the shell? We're talking about the concept of digital immortality. According to it, it's necessary to create a virtual copy of a person's personality in order to eventually transfer it into a suitable shell. To create a copy of a personality, you need to collect data about their manner of speech, behavior, and psychological assessments. A copy of the hormone and neurotransmitter systems will also be required, since they significantly affect how the brain works. To collect such a large amount of information, advanced technologies are required, but we already have projects that are engaged in collecting personal information. For example, in 2005, the Blue Brain Project was created, which is engaged in modeling the brain. The main goal of the project is to understand how the brain functions, and in the future to create biologically detailed reconstructions and simulations. At the moment, they are working on simulating a mouse brain. The concept of digital immortality has many critics. They argue that it is not truly immortality, since we are essentially making a copy of consciousness, not preserving the original version. Will we ever be able to live forever? We haven't found a definitive answer to this question in hundreds of thousands of years. However, we do have one way to live longer, only in the memories of other people. People live on as long as they are remembered. If we are remembered for our discoveries, achievements, and good deeds, we are, in essence, spiritually immortal. What do you think? Will we ever be able to become immortal? And which concept did you like the most?